4.3. In this lesson, we're going to learn about how to write linear functions in point-slope form. Recall the formula for finding the slope of a line. M equals y2 minus y1 over x2 minus x1. Or we can simply write it as M equals y minus y1 over x minus x1. Now we can use this slope formula to rewrite it in point-slope form by multiplying both sides by x minus x1. So we can cancel this out, and I'm going to rewrite the point-slope form down here. Y minus y1 equals to m times x minus x1. This is just another method that can be used to write a linear equation or, in other words, linear function. Guided practice, Part A. Write an equation in point-slope form of the line that passes through the given point and has the given slope m. So I'm going to write a random point for -3 with a slope of -2. So write y minus y1 equal to m times x minus x1, and now our goal is to substitute the given point into y1 and x1. Now watch carefully how I do this. Y minus -3 equals to -2 x minus 4. This is 4 because we have 4 here and it's considered positive, okay? And this negative sign here matches up with this negative sign. This negative sign matches up with this negative sign, or subtraction sign. It's okay. And now we can simplify. Negative negative makes positive. Y plus 3. And we can continue with this. -2 times the difference of x minus 4. And now we have this function written in point-slope form. Graph the equation. Okay, now before we graph the equation, we first need to look at this equation of the line here. We need to interpret it like this. Y minus -3 equals to 4 x minus 5. Rewrite it in point-slope form. Now, your point here will be 5, -3. Your slope here will be positive 4. So, to graph this, I'm going to have to first plot 5, -3. So I'm going to do that. 5 is right here, and I need to move down -3 units. 1, 2, 3. Now I need to look at the slope now. 4 over 1. So I'm going to need to shift 4 units up because it's changing y, and 1 unit to the right because it's changing x. 1, 2, 3, 4. Stop. And then 1 unit to the right. So my second point will be 6, 1. Now that I have 2 points, I can connect the dots, or the points. And if you plug in 6, 1 into the equation here, 6 minus 5 is 1 times 4 is 4, and 1 plus 4 is 4. So this point does lie on this equation of the line. So we're going to practice another one of graphing an equation that's written in point slope form. But I'm going to rewrite this as 1 minus negative 8 equals to 3x minus 0. So my point will be 0, negative 8. And then my slope will be 3. So this will be, I can rewrite this as 3 over 1. So we shift 3 units up and 1 unit to the right. Okay, so now I'm going to plot the point 0, negative 8. And now I'm going to shift 3 units up. Negative 8, negative 7, negative 6, negative 5. Stop here and then shift 1 unit to the right. So this is 2 here, so this must be 1. And stop right here. So my point should be 1, negative 5. And now I can connect my dots. Part D. Write an equation of the line that passes through the given points using the point slope form. Use the first point to write the equation. Before we write the equation, we need to first find the slope. So the slope will be given by the change in y, 8 minus 0, over the change in x, negative 8 minus 14. So this will be 8 over negative 22. And your slope, after you simplify this, will be negative 4 over 11. And now it says to use the first point, so I'm going to set it up. I'm going to rewrite y minus y1 equals to mx minus x1. Now, you don't have to write this if you don't want to. I'm just writing it to show you what I'm doing. So y minus 0 equals to the slope negative 4 over 11, x minus 14. So we're going to have to simplify this. Y equals negative 4 over 11 multiplied by the difference of x minus 14. And you have your equation of the line in point slope form. Part E. Tell whether the data in the table can be modeled by a linear equation. Explain. If possible, write an equation of the line in point slope form. Okay, now the strategy here is to compare the slopes between these points. 0 minus negative 4 gives you positive 4. 6 minus 3 gives you 3. So the slope between these first two pairs of points is 4 over 3. Now we can look at the next pair. 5 minus 0 is 5. 9 minus 6 is 3. So that's 5 over 3. Now let's look at one more pair. 9 minus 5 is 4. 12 minus 9 is 3. 4 over 3. Well, if we already have a pair whose slope is different from the first pair, we can just assume that these points won't form a linear equation. So we can write no, the slopes between the points are inconsistent. Part F. Find the value of k so that the line that passes through the given points has slope m. Write an equation of the line in point-slope form. Use the first point to write the equation. Okay, first we need to find the value of k. So I'm going to set up an equation here. 4k minus 2k. And then I'm going to take k plus 3 and put it in the denominator and subtract k. And we're going to let that equal to -2. So basically this is the slope formula, but instead you're given the slope and you need to solve for k. So 4k minus 2k gives you 2k. K and -k cancels out each other. So then we have 2k over 3, which equals to -2. So 2k equals -6. K equals to -3. Now once you have your value of k, you can evaluate these points to find out what they are. So for this first point here, k will be -3, and 2 times -3 will be -6. Now we don't have to evaluate the second point because the problem asks you to use the first point to write the equation in point-slope form. Now since we have the slope, we're ready. Y minus -6 equals to -2. X minus -3. So now y plus 6 equals to -2x plus 3. And that's our equation of the line in point-slope form. For the following word problems, you would have to use the point-slope form as a strategy to solve for your answer. So let's begin. You have designed a sticker to advertise your band. A company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. Write an equation that gives the total cost in dollars of stickers as a function of the number in thousands of stickers ordered. Now let me first write the point-slope form. Y minus y1 equals to mx minus x1. Now the word problem has given us many pieces of information in which we could match parts of the point-slope form to. So first of all, it has given us $225 for the first 1,000 stickers. We have been given the point 1,000 stickers. Now the reason why I'm using the word 1,000 is because I don't want to work with so many zeros. And 225. That's our first point. And then it says $80 for each additional 1,000 stickers. So that's our slope. I'm going to write it right here. $80 per additional 1,000 stickers. Then Y here will be your total cost. And then your X variable will be the number of stickers in thousands. Okay, so now let's set up your point slope form. Now you have a given point, y minus 225, and this equals to 80, which is the slope, and x minus 1. Now, I'm not going to use 1,000 because I don't want to work with big numbers. So I'm just going to simply use the number 1. Now we're going to continue to simplify this. Y would equal to 80x minus 80 plus 225. So y would equal to 80x plus 145. And now, lastly, it says find the cost of 9,000 stickers. So I can simply take this equation here and substitute in 9. Okay, recall that I didn't use the zeros when I substituted 1 here, so I could just simply use 9. Okay, plus 145, and after multiplying 80 by 9, which is 720, and adding that to 145 gives you $865. So I'm going to write the final answer here. This will be for 9,000 stickers. So again, the equation will be y equals 80x plus 145 and 865 for 9,000 stickers. From 1990 to 2000, the number of visits by people to Hawaii Volcanoes National Park increased by about 43.1 thousand visits per year. In 2000, there were about 1,529.6 thousand visits to the park. Okay, write an equation that gives the number of visits as a function of the number of years since 1990. Use point slope form to solve. So let me first write down the point slope form. Okay, because this may be your first time learning this, I'm going to take the time to explain which each variable represents. And in time, you don't have to write down so many details. Okay, so y here will be considered the number of visits. And x will be considered time, or number of years. And your slope will be 43.1. Now, between 1990 to 2000, there is a period of 10 years. Okay, and then by 2000, the visits resulted in 1,529.6. So here we can come up with a point. So now we can plug it in to the point slope form. And now we can simplify this. So now this will be the equation that represents the number of visits as a function of the number of years since 1990. Part B. How many visits were there to the park in 1993? Now, 1993 will be considered the third year from 1990. So I can take the equation in part A, y equals 43.1, and substitute x in for 3. And then solve. $1,227.9 thousand visits. The number of cans recycled per pound of aluminum in the U.S. increased at a relatively constant rate from 1972 to 2002. In 1977, about 23.5 cans per pound of aluminum were recycled. In 2000, about 33.1 cans per pound of aluminum were recycled. Find the constant rate of change. The constant rate of change simply refers to the slope. How fast was the recycling, the rate of recycling changing? So in 1977, this will be year 5 from 1972, and in 2000, this will be considered year 28 from 1972. And we can set up 2 points here. 5, 23.5, and 28, 33.1. And x will be considered the number of cans. Y will be considered the pounds. Now we can find the slope. 33.1 subtract 23.5 over 28 minus 5, which equals to 9.6 over 23, and this equals to 96 over 230, and you simplify to get 48 over 115. And you can also rewrite this in decimal form. And this would be considered the constant rate of change for the number of pounds of aluminum recycled. And this concludes our lesson.